Welcome to Narada Academy. In this video, we are going to discuss how to find whether the given infinite series is convergent or not. Already I have uploaded one video for infinite series. In that video, I have given the tests which are available for checking the convergence of a given infinite series. So in this video, we are going to discuss only the problems. So first you go through the video for which I have given the tests which are available for checking the convergence. So let's start with the problems. Test the convergence for each of the following series. The first one is summation un equal to 1 plus 2 by 3 plus 2 by 3 the whole square plus etc. 2 by 3 the whole power n minus 1 plus etc. See, this is a geometric progression, isn't it? With the common ratio r equal to 2 by 3 and its value is what, 0.67, which is less than 1. Okay, so whenever you are given with an infinite series which is of the form of a geometric progression, it will be convergent for r less than 1. If your r, the common ratio is greater than or equal to 1, the series will be divergent. Here the common ratio is what? 2 by 3, because you see all the terms are in multiples of 2 by 3, no? So this is a geometric progression with common ratio r equal to 2 by 3, which is less than 1. Therefore this is a convergent series. Okay, if you want to find out what is the limit, convergent means definitely it will have a limit, no? So if you want to find what is the limit of this convergent series, let us find out the partial sum. Sn, partial sum means what? Sum up to the first n terms. So 1 plus 2 by 3 plus 2 by 3 the whole square plus etc. 2 by 3 power n minus 1. The formula is a into 1 minus r power n by 1 minus r. So here a, the first term is 1 and r, the common ratio is 2 by 3. You substitute the values. So 1 minus 2 by 3 power n by 1 minus 2 by 3. So if you simplify, you will get 3 minus 3 into 2 by 3 power n. So this is the partial sum, nth partial sum. Now you take limit as n tends to infinity. See, this is something which is less than 1, no? So when n tends to infinity, this will become 0. Okay, if you take any decimal number and if you raise the power to higher number, that will tends to 0. So only this 3 alone you will get. So the limit of the partial sum is 3. So in an infinite series, okay, the limit of the partial sum is equal to the limit of the given infinite series. Therefore the given series is also convergent to 3. Okay, let's see the next problem. 1 plus 2 plus 3 plus etc. up to n plus etc. So this is the infinite series which contains all the natural numbers. So obviously this will be divergent. Okay, right? So let us check it properly. Here Sn, the partial sum Sn is given by sum up to the first n terms, no? So what is the formula? 1 by 2 into n plus 1. So as n tends to infinity, this approaches infinity. Therefore the given series is divergent. Okay, right. Next one is summation un equal to 2 minus 2 plus 2 minus 2 plus 2 minus 2 and so on, etc. So if by looking at this terms, you can easily identify this is containing alternately plus 2 and minus 2. So if you take the nth sum, that is nth partial sum, it will be 0 for even value of n and plus 2 for odd value of n. Okay, so this is oscillating. This partial sum is an oscillating sequence which oscillates between 0 and 2. Therefore the given series is also oscillating between 0 and 2. Okay, right. Then the next one is 1 plus 1 by 2 plus 1 by 3 plus etc. plus 1 by n plus etc. This is a very famous example both in sequence and series. When you talk about the sequence, it is convergent to 0. Okay, but in series actually it is not a convergent series. It diverges actually. Okay, let's check it correctly. Now let me consider the partial sum Sn and Sm. Sn means sum up to the n terms, Sm means sum up to the m terms. Now consider modulus Sn minus Sm. So it will be what? 1 by m plus 1 plus 1 by m plus 2 plus etc. up to 1 by n. Okay, in particular, if I take n equal to 2m, in that case, what will happen? Obviously, m plus 1 is less than 2m. So 1 by m plus 1 will be greater than 1 by 2m. So all these values will be what? Greater than 1 by 2m. So 1 by 2m plus 1 by 2m plus etc. 1 by 2m. So how many terms are here? M terms. So m number of 1 by 2m, it's equal to 1 by 2. So what I have arrived here is modulus of Sn minus Sm is greater than 1 by 2. Okay, that implies what? It is greater than some value means it is a divergent sequence. So the partial sums is divergent. Therefore, the given series is also a divergent series. Okay, then next one. The next sequence is square root of 1 by 4 plus square root of 2 by 6 plus etc. square root of n by 2n plus 2 into n plus 1. Here what I am going to do is, this is the nth term, no? You check limit n tends to infinity un. Okay, we have a theorem that if we have a convergent series, then limit n tends to infinity un must be equal to 0. Okay, so if it is a convergent, then n tends to infinity un equal to what? 0. But the converse is not true, right? Okay, so how will you use that statement here? If the nth term tends to 0 as n tends to infinity, we cannot say anything about the convergence. But if the nth term is not equal to 0 as n tends to infinity, then definitely the series is not a convergent one. So that is what I am going to do here. This is my nth term. Now you simplify this term. You cancel n from the numerator and denominator. I am getting 1 by 2 into 1 plus 1 by n the whole to the power of half. As n tends to infinity, this reduces to square root of 1 by 2, which is a non-zero term. So n tends to infinity un is non-zero. That means the given series is not convergent. Okay, right. See, if a problem is given, you can check the convergence in so many different ways. Okay, so by continuous practice, you can identify which test will give you the result quickly. Okay, you can make use of any of the tests available. Now consider the next problem. 1 by 5 plus root 2 by 7 plus root 3 by 9 plus root 4 by 11 plus etc. So here un is given by root of n by 2n plus 3, which is positive for all values of n. Now let me take vn equal to 1 by root of n. Okay, right? Then what will be un by vn? This n and n cancel, no? Root n, no. Root n into root n will become n by 2n plus 3. So after simplification, what will I get? 1 by 2 plus 3 by n. Right? As n tends to infinity, un by vn equal to 1 by 2. This is a finite and non-zero number. This is another test which states whenever you have limit n tends to infinity, un by vn is a finite and non-zero number, then un and vn converge or diverge together. Okay, but for Vn, this is a divergent series because 1 by n power p converges for p greater than 1 and diverges for p less than or equal to 1. Here, n power half only, no, half means what? Less than 1. Therefore, this Vn is a divergent series. So, since limit n tends to infinity, un by Vn is equal to 1 by 2, which is finite and non-zero, un and Vn both converge or diverge together. Therefore, as Vn is divergent, un is also divergent. Okay, then next problem. Un equal to square root of n power 4 plus 1 minus n square. Now multiply and divide by root of n power 4 plus 1 plus n square. So what you have? N power 4 plus 1 minus n power 4 by, in the denominator you take n square outside. So this will be 1 plus square root of 1 plus 1 by n power 4. So in the numerator, n power 4 will get cancelled. You will simply get 1 by n square into 1 plus root of 1 plus 1 by n power 4. Now let me take this 1 by n square as my Vn. So this is a convergent series because here n to the power of 2, no, 2 is greater than 1. So this is a convergent series. Now what is un by Vn? Un by Vn means this 1 by n square will get cancelled. So simply you have 1 by 1 plus root of 1 plus 1 by n power 4. So as n tends to infinity, this is equal to 1 by 2, which is finite and non-zero. So as discussed in the previous problem, both un and vn are convergent or divergent together. But we know this vn is convergent as this is of the form 1 by n power p with p equal to 2, which is greater than 1. Therefore, the given series is also a convergent series. Next one, un equal to sigma un equal to root 2 minus 1, root 5 minus 2 plus root 10 minus 3, etc. So from this un equal to what? Root of n square plus 1 minus n. So multiply and divide by root of n square plus 1 plus n. So what will you get? N square plus 1 minus n square by n plus root of 1 plus n square. So n square get cancelled. So 1 by, you take n outside, n into 1 plus root of 1 by 1 plus n square. So this is my un. Now let me take Vn equal to 1 by n. So this will be a divergent series. Now un by Vn equal to 1 by 1 plus root of 1 plus n square. So as n tends to infinity, this term is 1 by 2, which is finite and non-zero. Therefore both un and Vn are converge or diverge together. Since Vn is divergent, sigma un is also divergent. Next one, sigma un equal to sigma 1 by n sine 1 by n. Okay, we want to discuss the convergence of this. So we can do it in two different ways. Let me explain the simplest way first. Let me take x equal to 1 by n. See, look at this portion. X equal to 1 by n. Then n tends to infinity means x tends to 0. Therefore, limit n tends to infinity, 1 by n sine 1 by n equal to limit x tends to 0 sine x by x. Okay, but this limit we know it is equal to 1, isn't it? Therefore, the given series is a convergent series. This is one simplest way. The another way is by writing the expansion. What is the expansion for sine theta? Theta minus theta cube by 3 factorial plus theta power 5 by 5 factorial minus etc. So in that way you expand this. So 1 by n into, from this you take 1 by n outside, 1 minus 1 by n square into 3 factorial plus 1 by n power 4 into 5 factorial etc. So it is 1 by n square into terms. Now you take Vn equal to 1 by n square. Here this is of the form 1 by n power p with p equal to 2. Therefore this is a convergent series. Now un by Vn equal to, you will get this term alone, no? So as n tends to infinity, all these terms will become 0. We will get simply 1. So this is a finite and non-zero quantity. Therefore un and Vn converge or diverge together. But we know Vn is convergent. Therefore un is also convergent. So if you want to check whether it is convergent or divergent, you can use this way. If you want to find the limit, you can go with this one. Next one, sigma un equal to sigma cos 1 by n. Now this is my un, no? See, as n tends to infinity, it will become what? Cos 0. Cos 0 is 1, which is non-zero. So what I told you already, if limit of un as n tends to infinity is non-zero, the series is not convergent one. Therefore, this is not convergent. But this is a series of positive terms only, no? Therefore, it must be what? Divergent. Okay. Then, next problem. Sigma 1 by root n tan 1 by n. Now, this is the given series. Now, let me take Vn equal to 1 by n power 3 by 2. 3 by 2 means what? 1.5. Therefore, this is a convergent series. Now, what is un by Vn? 1 by root n tan 1 by n by 1 by n power 3 by 2. So simply I get n tan 1 by n. This can be rewritten as tan 1 by n by 1 by n. So as n tends to infinity, this one tends to 1. As like in the sine problem, this tends to 1, which is finite and non-zero quantity. Therefore un and Vn converge or diverge together. But we know Vn is convergent. Therefore un is also a convergent one. Next one, sigma un equal to 1 by log 2 plus 1 by log 3 plus 1 by log 4 plus etc. See, whenever you have log n is always less than n. Therefore, 1 by log n is greater than 1 by n. Okay, so summation un, this is my un, no? Summation un is greater than summation vn. This is my vn. Now, this vn is dominated by this un. That is, all these terms are less than terms of this series. But we know this is a divergent series. In the previous examples, we have proved that this one on the right hand side is a divergent series. So the smaller one itself is divergent. Therefore, the bigger one definitely will be a divergent one. Okay. The next problem, 1 plus 2 factorial by 2 square plus 3 factorial by 3 cube plus etc. So un is n factorial by n power n. Un plus 1 is n plus 1 factorial by n plus 1 power n plus 1. Now un by un plus 1 equal to, okay, you write the values and you simplify. Simply what you get, 1 plus 1 by n power n. So as n tends to infinity, un by un plus 1 is equal to e, which is greater than 1. E means what? It is 2.7 something, no? So it is greater than 1. So by D'Alembert's ratio test, what we conclude, if the value is greater than, limit is greater than 1, the series is a convergent series. Okay. Next problem, 1 by 2 plus 1 into 3 by 2 into 4 plus 1, 3, 5 by 2, 4, 6 plus etc. So write un and un plus 1 and you find what is un by un plus 1. I am getting it as 2n plus 2 by 2n plus 1. So as n tends to infinity, this is equal to 1. So the ratio test, D'Alembert's ratio test fails when the limit is equal to 1. So whenever you get the terms like this, you can make use of Rabb's test. So for Rabb's test, you have to multiply this term by n. That is n into un by un plus 1 minus 1. So it's equal to n into 2n plus 2 by 2n plus 1 minus 1. So it is simply n by 2n plus 1, which is 1 by 2 plus 1 by n. So as n tends to infinity, this is 1 by 2, which is less than 1. So by Rabb's test, this is a divergent series. Okay. Next problem, 1 plus 2 square by 3 square plus 2 square into 4 square by 3 square into 5 square plus etc. Now this is u1 equal to 1 for n equal to 2, 3 etc. un is given by means of this and un plus 1 is this. How will you write un and un plus 1? See, for un in the numerator you are getting all even terms, no? So 2 square, 4 square etc. up to 2n square. Denominator all odd powers. So 3 square, 5 square etc. 2n plus 1 the whole square. For writing the next term, this is 2n means what will be the next term? 2n plus 2. Next even term will be 2n plus 2. This is 2n plus 1 means next odd term will be 2n plus 3. So in that way you have to write. So if you divide un by un plus 1, you are getting 2n plus 3 the whole square by 2n plus 2 the whole square. Now you take n outside and you cancel n from numerator and denominator. Simply you get 1 plus 3 by 2n the whole square by 1 plus 1 by n the whole square. As n tends to infinity, this is equal to 1. So D'Alembert's ratio test is a failure one here. So let me try Gauss test. Okay, so for that let me rewrite un by un plus 1 using binomial expansion. Here 1 plus, this is like a plus b the whole square, no? So you write the expansion. This is like 1 plus x the whole power minus n. So what's the formula? 1 minus 2x plus 3x square minus 4x cube etc. Okay, now you collect the terms. Only you write constant, terms containing 1 by n and 1 by n square. Other terms you can leave. Okay, so simply what I get, 1 plus 1 by n minus 3 by 4 n square. Gauss test, compare it with Gauss test. Here the constant is alpha and coefficient of 1 by n is beta and the remaining coefficients are gamma. Okay, if here alpha equal to 1 and beta equal to 1, the test says for alpha equal to 1, if beta is less than or equal to 1, the series is a divergent series. So here beta equal to 1, therefore the series is a divergent series. Okay, next one, x by 1 plus 1 by 2 into x cube by 3 plus 1 into 3 by 2 into 4 x power 5 by 5 plus etc. Now write un. So un is what? 1, 3, 5 etc. up to 2n minus 1 by 2, 4, 6 etc. up to 2n x power 2n plus 1 by 2n plus 1. And similarly you can write un plus 1 and find un by un plus 1. So simply what I get, 2n plus 2 into 2n plus 3 by 2n plus 1 the whole square into 1 by x square. Okay, now you cancel n from numerator and denominator. So as n tends to infinity, this tends to 1 by x square. So the series converges or diverges based on the value of x square. Okay, so if this is greater than 1, that is 1 by x square is greater than 1, it is convergent. That means what? X square is less than 1 means the given series is convergent. If x square is greater than 1, it is a divergent one. And the test is failed when this value is equal to, that is x square equal to 1. Okay, so we have to check what happens when x equal to 1. So when x equal to 1, un by un plus 1 takes the form 1 plus 1 by n, 1 plus 3 by 2n into 1 plus divided by 1 plus 1 by 2n square. Bring it to the numerator and you expand using binomial expansion and then you write the terms as before. We are going to apply Gauss test. So Gauss test contain terms constant plus 1 by n term plus other terms. So constant is alpha, 1 by n, coefficient of 1 by n is beta. So when alpha equal to 1 and beta greater than 1, the series is convergent. Therefore, for x square equal to 1, the series converges. Okay, right? Next problem, x plus 2 square into x square by 2 factorial, 3 cube into x cube by 3 factorial plus 4 power 4 x power 4 by 4 factorial plus etc. As in the previous problem, you write un and un plus 1. Find what is un by un plus 1. I am getting it as, okay, 1 by ex, because here I am getting limit n tends to infinity 1 by 1 plus 1 by n the whole power n, so 1 by ex. So whenever you have terms containing exponential, see by D'Alembert's ratio test, it converges when 1 by Ex greater than 1. That is, x is less than 1 by E. And divergent for x greater than 1 by E. And when x equal to 1 by E, it will become 1, no? So the test fails. So for x equal to 1 by E, what happens? Let's check. Un by Un plus 1 equal to 1 by 1 plus 1 by n power n into E. So as n tends to infinity, what happens? This equal to, now whenever you get E, that is exponential in the ratio, you have to make use of logarithmic test. Now you take log on both sides. So log Un by Un plus 1 equal to log E plus log of 1 by 1 plus 1 by n power n. So log E is 1, no? So 1 minus log of 1 plus 1 by n power n. So here I bring it to the numerator and I change the sign here. So 1 minus n into log of 1 plus 1 by n. So you apply the logarithmic expansion, 1 by n minus 1 by 2n square plus 1 by 3n cube minus etc. So now you simplify. So what you get? 1 by 2n minus 1 by 3n square etc. Now n into log of Un by Un plus 1 is simply 1 by 2 minus 1 by 3n plus etc. By logarithmic test, okay, as limit n tends to infinity, this value is equal to 1 by 2, which is less than 1, no? So this is divergent 1. For greater than 1, it will be convergent. Since this is less than 1, it is a divergent 1. So for x equal to 1 by E, the series is divergent. Next problem, 1 minus 1 by 2 plus 1 by 3 minus 1 by 4 plus etc. So Un is minus 1 power n minus 1 by n. Here see, 1 by n is always greater than 1 by n plus 1, no? Also, n as n tends to infinity, Un equal to 0. Therefore, the Leibniz test, the conditions for Leibniz test are satisfied. Therefore, by Leibniz test, this is a convergent series. Okay, when this is an alternating series, whenever you are given with an alternating series, if the series is convergent, let us check for absolute convergence. Absolute convergence means change all the terms to positive sign. That is sigma modulus Un equal to sigma 1 by n. But we know very well that this is a divergent series. So the given original series is convergent, but the modulus of the given series is divergent. Therefore, this is a conditionally convergent series. Okay, right? The next problem. 1 by root 2 plus 1 minus 1 by root 3 plus 1 plus 1 by root 4 plus 1 etc. So sigma Un is sigma minus 1 power n minus 1 by root n plus 1 plus 1. So the conditions for Leibniz test are satisfied. That is 1 by root n plus 1 plus 1 is greater than 1 by root n plus 2 plus 1. Also as n tends to infinity, this value tends to 0. Okay, therefore by Leibniz test, it's a convergent series. Now let's check for absolute convergence. Sigma modulus Un equal to what? 1 by root n plus 1 plus 1. So root n you take outside, 1 by root n plus root of 1 plus 1 by n. Now you take this as a Vn equal to 1 by root n. This is divergent because this is like 1 by n power p, where p equal to half, which is less than 1. So this is divergent. Now Un by Vn equal to 1 by root of 1 plus 1 by n plus 1 by root n. So as n tends to infinity, this is equal to 1, which is finite and non-zero. Therefore Un and Vn converge or diverge together. Since Vn is divergent, the given series is also divergent. Okay, so what we have proved here, the original series is convergent, but the absolute convergence is not there. Therefore, the given series is conditionally convergent. Okay, then next problem. Sigma n equal to 2 to infinity 1 by n log n power p. Okay, this is my Un. For p equal to 0, simply 1. Therefore, as n tends to infinity, it is equal to 1 only, no? Therefore, it is a divergent series. For p less than 0, let p equal to minus q. In that case, Un equal to what? N power q into log n power q. As n tends to infinity, this tends to infinity. Therefore, it is divergent. So, for p less than 0 and equal to 0, it is divergent. What about for p greater than 0? For p greater than 0, n log n power p is obviously an increasing sequence. Okay. Therefore, 1 by n log n power p will be a decreasing sequence. Okay. That is Un is greater than Un plus 1. So, by Cauchy's condensation test, sigma Un and sigma 2 power n u 2 power n converge or diverge together. So, let me check what is sigma 2 power n u 2 power n. So, replace all n by 2 power n. Okay, so 2 power n by 1 by 2 power n p log 2 power n power p. So, it's equal to, now you combine these two terms together, sigma 2 power n into 1 minus p, 1 by n log 2 power p. So, now you log 2 is independent of n, so I am taking it outside, 1 by log 2 power p, sigma n equal to 2 to infinity, what? 2 power n into 1 minus p by n power p. This is my summation 2 power n, what? u power u 2 power n. So let us check the convergence or divergence of this series. For p greater than 1, 2 power n into 1 minus p is less than 1, isn't it? P is greater than 1 means what? This will be negative power, so it will be less than 1. Therefore 2 power n into 1 minus p by, divide both sides by n power p. So 2 power n into 1 minus p by n power p is less than 1 by n power p. This one is convergent, that is terms on the right hand side is convergent only for p greater than 1. Therefore on the left hand side is also convergent for only for p greater than 1. Okay, so the given series is convergent for p greater than 1. For p equal to 1, what happens? Sigma 2 power n u 2 power n is equal to 1 by log 2 summation 1 by n. This is a divergent series. Therefore for p equal to 1 is also it is divergent. But for p less than 1, 1 minus p is greater than 0, no? So 2 power n into 1 minus p is obviously greater than 1. Divide both sides by n power p. Now this is divergent for p less than 1. P less than 1 only we have taken here. So this is divergent. Therefore this is also divergent. Therefore, so finally what do we conclude? For p greater than 1 only the series is convergent. For p less than or equal to 1 the series is a divergent series. Okay, that's all. Thank you.